With the beams, we're looking mainly for deflection, damages, and things like that. This is a list. This list is going to be shown over and over again. And it pretty much goes to the whole structure. I get it, all right? So if we're putting all our load in one spot, that's probably where we're going to overload that beam and we're going to see some sort of movement and damage to it. Don't be surprised when you see a beam sitting on the wood itself and then all of a sudden you see the beam where it's compressing up underneath that wood post. It happens, all right? Lateral support, anything that's missing, anything that's notched or holed, leaning, past repairs, wood rot, termites, rotating, twisting, especially when we're dealing with beams. They get their strength from being directly up and down. Once I start letting them rock, then I'm going to run into problems. Steel, when steel starts to rust, it's going to expand at first, and then once that rust weakens the actual structure, then it's going to start to sag. All right, and those connections, to the post and columns and joists, I got to say that about 90% of the homes that I go into, those bolts that tie the post and the beams together, they're always loose. And I don't know what to say. There's so much weight on there that I've never really seen any of those move. Can it? Yeah. Should they be tightened? Why not? But I really don't think it's the end of the world. They've been that way for a long time. All right. So when we're dealing with concrete floors, I would like you to be able to recognize two different methods to put concrete floors up. One of them is going to be post-tensioning the concrete, where the other one's going to be pre-stressing the concrete. Notice the diagrams are basically the same. All right. It's basically when we're putting the stresses on this concrete, whether we're doing it in the factory or we're doing it on the job site. All right. So concrete, we mentioned, is strong in compression. All right. But yet, when I put concrete as a horizontal surface like this, the bottom is going to be under tension, while the top is going to be under compression. So I need to, because concrete's weak in tension, I need to somehow strengthen up that weakness in tension. So these drawings, as you're seeing here, they're going to run a steel rod along the bottom inside these different holes in there, and they're going to squeeze these things in together and put pressure on that concrete and squish it together. And as long as I'm compressing it, I'm going to go ahead and make it much, much stronger where it comes in here. So pre-stress, we do that in the factories and we deliver it. Post-tension, there's going to be holes that are present. We're going to end up running the steel rods through it. There's going to be bolts, and then they're going to crank them down until they get to the right amount of tension on that steel that's on there as well. Mike added on here the Simpson straw tie makes retrofit anchor bolts, and they're not the only manufacturer of stuff like that, so there are other ways around it. And we're not going to know always what's sticking or what is in there just because we're not going to be able to see it. So again, grabbing them and moving them, not such a bad thing. Talking about the anchor bolts. All right. So concrete slabs in the floor, and I use the term 1/4 inch, and here it says larger than 1/8 of an inch. So it's kind of the same thing. But concrete slabs on the floor, some of these things are shrinkage cracks, where some of them are more serious where it comes into it. Alright, I lost my ability to change things here. I'm going to skip out of this just for a second. This way I can see things again. Good, sorry about that. And then let's go back to here. And since I know I could zoom in a little bit more again, we're going to go ahead and zoom in where we were. Alright, so we were talking about cracks in the floors as well. And clean real quickly here. Alrighty. So now we're going to do a little bird's eye view. On here we're going to talk about the different types of cracks that we may be seeing. That was a little wet there, sorry. Alright, so we're bird's eye view. We're looking straight down. L-shaped house is what we're looking at here. And let's put a few posts in here. Out in the middle. Okay. So if I start seeing cracks around the post that more or less go in a circle pattern like that, you start, and maybe you'll see them in different rings coming around here as well. Anything that's a circular motion like that is settlement or heaving or settling, all right? And that's what they're showing in, that was in the diagram beforehand. So it's going up or down. When I start seeing cracks where they just come off the corners like that, that's normal. Those don't bother me at all. Those are typical shrinkage cracks when we come into things, and it's common. All right. In fact, remember that 90-degree angle thing that we were talking about beforehand? So right in this area, when I have this inside turn, that's probably one of the most common areas. And because I'm going to have another 4 90-degree turns, just like what this here, these are going to be common areas where I'm going to get the cracking. Many times you're going to actually see a crack going from a post right to that corner. All right. That's normal. All right, as long as they're not uneven, we're not getting water coming through it. Sometimes they're going to put control joints in there, so they'll actually notch it, which is a great idea. They're going to put a control joint right into this area here, hoping to cause that crack to occur right there. So if we got cracking inside of a control joint, it was designed to do that. All right, that's not a bad thing when that happens. Now, if I get a crack where it's going all the way across and then it's going up the wall this way and up the wall that way, that pretty much tells me this whole section is dropping down. So I'm going to probably want to look and see outside if there's any sort of water, such as sloping sidewalks, sloping driveways, sloping earth, anything that's directing water to cause that part of the house to settle. If I see a crack in the floor going across, and again, you know, angles going up into the corners. Sorry about that. And an angle's going up into the corners up in here. I'm going to be focusing on discharges and water coming into that corner. So typically, if I get settlement from water, I'm going to have sister cracks. All right, there's going to be typically 2 of them. Posts that go up and down, we're going to have circles around them. Anything that has kind of like a spiderweb crack on it, those are common for. Those are going to be common for shrinkage or curing of the concrete, and quite frankly, I don't really consider that a big deal whatsoever. All right. Let's go back and get this on here again. All right. Oh, I think I know what's happening here. Okay. So if it's hollow below a concrete slab, and in this drawing we're showing pre-stressed or pre-stressed or post-tensioning on the slab. We may have basement underneath the garage. All right, it is doable. This will support that weight, and we don't have to worry about what's underneath it. And I have run into houses like that before. All right, and I'm sure you will too. When it comes in there, all garage parking decks are kind of that way. So the engineers can design this to make sure that it works. However, if they're not, and it's just standard concrete, and we do start getting a lot of settlement, that's when you're going to see dipping and changes and everything right over here. All right, we'll go through some of these slides. If we're seeing that the pieces are missing, rusted, rust stains coming through to it, we know things are going to be moving. Our main goal is to see if it has been moving or settling when it comes to it. Uneven surfaces, for us, we go with 3/4 inches, our line in the sand. We call that a trip hazard. And of course, any water coming in is always something that we recommend that people get repaired. Most settling is considered minor. However, if it's a constant ongoing thing, it can be catastrophic. It can be very expensive. I remember I did one house that had so much settling, and it was what they call a 203K loan. And they had to borrow $100,000 just to get all the supporting piers going all the way around the outside of the house. It was a big home, but $100,000 is a lot of money. At least to me it is. All right. Spalling is any time water gets in between the layers, freezes, and pushes off the face of the concrete. Sometimes you'll see spalling if the slurry or the cream coat on the concrete was too thin, and just by people walking on it is enough to make it come loose. So it does happen with the spalling. When we start getting into wall framing right now, like a few other words I want you to know is shear and shear walls. So what we're talking on this drawing here is an actual shear wall. So when we use plywood, OSB, anything that's hardwood on here, and we use that in the corners, that's got its strength is to keep my wall studs from shifting or racking when it comes into it. Its weakness is it's a pretty solid material, so it's a very poor insulator when it comes with it. So for most of the time, we want to use a decent insulation. So a styrofoam, a sheathing, maybe a sheetrock, something that's going to create, the lighter it is, the better the insulation value that's going to be in there. All right. Studs are going up and down. In our area, we're very common with 16 inches on center. I think you're going to start seeing more of 2x6 framing, and they're typically going to go 2 foot on center. I think we're going to see a lot of changes to that in the upcoming future. The less wood, we're getting more into energy conservation and less onto the strength of the structure. So if the engineers can prove that, hey, building these things 2 foot on center is just as strong, with the thicker lumber, and yet if we get rid of, 1 out of every 4, or actually it's 2 out of every 4, isn't it? But we'll say 1 out of every 3. 1 out of every 3 studs, then we have less places where we're going to get that heat transfer through condensation, because you get that thermal bridging through the 2x4 studs that much more. So the goal is to insulate houses and make it more energy efficient. So the first one was a shear wall. This is called a shear brace. I know it says shear wall on there. Please forgive me. This is a brace. And doing this, now all of my sheathing back here can all be some sort of insulated material. So I think we're going to start going back to this type of framing to where, so we can get more insulation in there, less studs, and so forth. And again, we make a triangle out of this. So up, down, across, and that's the main goal, is to prevent the wall from racking or coming into it. I know this, this obviously is a garage, and but when houses are finished and we insulate them and we cover them with drywall, we don't have the luxury of seeing the structure anymore. That's what's nice about these. So here we got styrofoam insulation. That's what the yellow stuff is here. We do have shear walls over here in the corner. These are 2x4 separations in between here. And these are 2x6 studs that come in there as well. And again, I think this is, you could also see in our corners, they're going to be using less lumber. What used to be 3 or 4 pieces of lumber in here, they're trying to get by with only 1 or 2, and then put some little more blocking. And that way in the corner, you could start filling these things in with foam. It's just, I forgot what it's called. It's OVE. I know that's the acronym, but I can't remember what OVE stands for. But yeah, it'll probably come to me, or hopefully somebody will type it in here and then I'll share with you. But it's just another building technique, and it's the way to make it more energy efficient, use less wood, and protect our environment a little bit more. Top plates. So you can actually get by with a single top plate. It is allowable, all right? But when we do top plates, and I guess I should go back here, this one, if we look at the top up here, we do have a single top plate on this one. But notice that my stud is directly below that truss, and this stud is directly below that truss, all right? So all the load-bearing points need to be solid from top to bottom. I cannot have a truss fall in between here while I have a single top plate. When I put the double top plates up here, so here we got 2 of them, 2 things it does. It gives me a way to tie in my perpendicular walls easier, okay, which is nice. Makes things a little bit more solid. But now I can also put my floor joist anywhere. All right, having these doubled up on here means I don't have to land directly on top of the stud that's below it. Or if I'm putting up, if it's an exterior wall and I'm putting up trusses, then those again, they won't have to land right onto the wall. All right. Headers, top plates, studs are 16 inches on center, sole plates are on the bottom. And I'm going to do this quick and move along on it. So the sole plate is the bottom piece of lumber that's going on top of the deck. Studs are going on top, or straight up and down, I'm sorry. And then on top we have a double top plate. Our header is the load bearing that supports our opening. And then these are cripples or mini studs that bring it down. Now remember, here we put our board up underneath here. Now as long as all we're doing is putting a window in there, or maybe an overhead door, optimum value engineering. Thank you very much. I love you guys. I remember the acronym, but I couldn't remember what the words meant. OVE stands for Optimum Value Engineering. Luke Mulligan, thank you very much. All right. So going back onto our studs, we have that bottom 2x4 piece of lumber going all the way across. Most of the time they're just going to shoot nails in there. Probably won't create an issue unless we're going to try and use that as support that comes in there. All right. Trimmers, cripples, anytime we have anything shorter than a complete stud is when these things come in here. We mentioned before about floor joists are 1.5 inches. Headers and girders are 3 inches. Same thing with headers. Depending on the length of the header and how much weight it's supporting, sometimes I can get by with 1.5 inches support for that header. Sometimes I'm going to need 3 inches of support. All right. Some more rules that come into play if a wall is load bearing or not. We are allowed to make holes and make notches into them, run plumbing, electric, but there's only a limited amount that has to come in there. So for load bearing walls, holes are 40%, notches 25%. Non-load bearing walls, you can go up to 60%. Notches are 40%. Anytime I get within 1.5 inches, I believe, I keep forgetting if that's 1.5 inches or 1.25 inches, but anytime I get within 1.5 inches of the surface area, then I need to put a nailing plate for protection. So whatever I'm running through that hole, if it's a plumbing pipe or electrical or whatever. And in our area, because we deal with conduit, we're not so much worried about the electric, but we are worried about the plumbing. We need to have plates on there so the drywall guys can't drive screws into it. I do want you to remember 40 and 60 and 25 and 40, depending if it's load bearing or non-load bearing. All right.